Hello, welcome to the second lecture on local area networks. In the first lecture, we have discussed various topologies that are used in local area networks. We have discussed their advantages and disadvantages. And in this lecture, we shall consider the second important parameter or issue related to local area network, that is medium access control techniques. As we know, in a multi-access media, in a multi-access medium, we need a protocol for effective sharing of the media that you are using in a particular application. The basic question that has to be answered by medium access control technique is, who goes next? The situation is, here you have got a multi-access media to which a number of nodes are connected, number of stations are connected. Here, since the media is shared, at a time only one of the stations can transmit. Question will arise, who will be transmitting next? That has to be decided by medium access control technique. Why it is necessary? Whenever more than one station starts sending simultaneously, the signal gets garbled. Garbled whenever more than one station sends simultaneously. That situation is called collision. So, in addition to who goes next, the medium access control technique has to answer or has to avoid collision. So, medium access control technique will be used to avoid collision, and it will tell who will be accessing the medium next. Let us see what are the goals of MAC, medium access control technique. First operation or first goal that has to be performed is initialization. As the system is powered on, you have to bring the station to a desired state so that it can start functioning. For that purpose, the station has to be initialized with proper state of the machine. That has to be done by the medium access control technique. Second is fairness. Fairness is necessary because when you have a large number of stations sharing a common media, multi-access media, each and every station is waiting to gain access of the medium. Obviously, how long one station has to wait, and after getting access to the media, how long it can control the media, how long it can transmit data before relinquishing control. So this fairness has to be decided. This is called the fairness. That means after how much time the access can be obtained and for how much time has to be waited, and second is how long the medium can be controlled or what is the maximum length of packet that can be sent. So this is decided by the fairness. It has to be fair. In addition to the fairness, another important goal of medium access control techniques is to provide priority. In a computer network, the data that are being communicated can be of different priority. Some can be for real-time control, say audio, video, and so on. That type of data has to be provided with higher priority. So medium access control technique has to be able to provide suitable priority so that high priority data can be allowed to be sent before low priority data. Then another goal is limitation to one station. As you have seen, medium access control technique has to identify which station will be sending next. It should not select more than one station because in that case a collision will occur. So to avoid collision, only one station has to be selected which will be transmitting next by the medium access control technique. That is another goal of medium access control techniques. Then error limitation. The medium access control technique should allow detection of error when the communication is taking place. And whenever an error occurs, it should allow recovery from error. Recovery from error as well as from collision. So whenever a collision occurs, you have to recover from the collision situation, and that has to be done provided by the medium access control technique. Then it has to be reconfigurable. That means in a network you have a limited number of stations. If you want to add another station, your medium access control technique should allow the insertion of a station, removal of a station, with ease. Obviously insertion and removal has to be done, but it has to be done with ease without any problem. Then you have to provide proper receipt. What do you mean by proper receipt? A station is sending to a destination station. A source station is sending to a destination station. That packet has to be delivered to the destination station only, and in the process there should not be no loss. That means no lost packet, no duplicate packet, same packet should not be delivered twice. A packet should be delivered only once, and we have to develop mechanism in the medium access control protocol so that a packet is not delivered twice. Similarly, a sequence of packets are to be delivered in proper order. Then you have to use compatibility. Later on, when we shall be discussing various medium access control techniques, we have to ensure that one medium access control technique can interoperate, can become compatible with other medium access control technique, so that in a single network we can have different types of medium access control techniques, and that compatibility has to be achieved by the medium access control technique. Finally, reliability. A medium access control technique should ensure reliability of the network. So whenever a station fails, whenever a link fails, whenever you have got multiple links, in spite of that, the system of that network should work without, maybe with degraded performance, but it should not stop functioning. And that's how the reliability can be achieved by suitable design of the medium access control protocol. So with these goals, you have to design or develop a medium access control technique. Let us see what are the different elements of medium access control techniques. Different elements of MAC, medium access control technique. First point is where. By that we mean where the control is exercised, where the control is exercised. There are two alternatives. One is centralized, the control can be exercised in a centralized manner, because a centralized control system, centralized mechanism, has several advantages. For example, it has greater control to provide features like priority, overrides, and guaranteed bandwidth. We have seen that priority is necessary when the data is of different nature. Some of them are for real control, some of them are for ordinary data communication, and real-time data has to be provided with higher priority. And a centralized control allows you to implement this priority overrides. That means, say one communication is going on, that can be stopped and a higher priority data transmission can be started. That can be done by using centralized scheme. And the guaranteed bandwidth can be provided to some of the data communication approaches or data communication links or some of the processes, so that the real-time data can be communicated using this guaranteed bandwidth. Then this centralized scheme also provides you simpler logic at each node. The functionality of the node is very simple here, because the medium access control is performed by a central node, and each node is free from this particular function. and as a consequence it can be very simple. Finally, it allows you easy coordination. Although it has these advantages, there is one problem in this. It is vulnerable to failure. Why it is vulnerable to failure? The central node, which is responsible for medium access control, if it fails, the entire system will collapse. The network will not be able to function. And as a consequence, this centralized scheme, although has a number of advantages, it is vulnerable to failure and it is not used in practice, or it is not popular. Let us see what are the other alternatives. Second approach that can be used is distributed. In this particular case, the stations, various stations which are in the network, stations collectively perform MAC. So it is not the responsibility of a central node, it is performed by all the stations in a collective manner. And it is done in a dynamic way, because each of the stations is taking part in it. If a particular node fails, it does not matter, because all the nodes are provided with the capability of performing medium access control, and as a result it provides you very high reliability. But nothing comes with some price. You have to pay the price for it. The price for it is high complexity in each station. That means the functionality of each of the stations in this particular case is more, because the medium access control technique is distributed. Each station has to perform the medium access control operation in a distributed manner, and so the complexity of each station is more. Second parameter, second element is where and let us see how. Second element of the medium access control is how it has to be performed. So this how decides in what manner the control is exercised. And obviously, this is constrained by topology. It is constrained by topology, and also the trade-off between cost performance and complexity. Whenever it is very complex, cost of implementation is high. So cost performance and complexity trade-off will be decide how it is being implemented. And you have to use some multiplexing technique a suitable multiplexing technique has to be used for this purpose. Let us see what are the different multiplexing techniques that can be used to implement a medium access control technique. Multiplexing techniques. We have seen that when we discussed various multiplexing techniques, if the bandwidth of a medium has to be shared by multiple stations, we have to use some multiplexing technique. We have already discussed the frequency division multiplexing technique, time division multiplexing technique, then synchronous time division multiplexing technique, asynchronous time division multiplexing technique. These are the techniques which has to be used in this case. So we know that the multiplexing techniques can be broadly divided into two types. One is known as FDM, frequency division multiplexing. Frequency division multiplexing technique is used where the frequency spectrum is divided among all the stations, and different stations uses different frequency bands for the purpose of communication, as it is done in case of cable TV, and also this is being done in your other applications like cable TV, various other applications. Then another approach is TDM, time division multiplexing. The time division multiplexing, in which for different amounts of time is allocated to different stations for communication of data. And we know that there are two possible alternatives. One is synchronous, the synchronous technique is used in your public telephone networks. And as we know, this synchronous technique is not suitable for computer network communication, because here the nature of traffic is bursty. It's not continuous, not streamed. And as a consequence, this synchronous mode of communication cannot be used, but we have to use what is known as frequency division multiplexing, FDM. We have to use asynchronous mode. CHRONOUS. And this asynchronous mode is suitable for bursty nature of traffic. And under this asynchronous category, there are three possible alternatives. Number one is round robin. Second is contention based. Third is reservation based. We shall discuss in our computer networks, this asynchronous technique is used using one of the three possible approaches. We shall consider these three approaches one after the other. Let us first of all consider the round robin. In round robin, how it is being done? What are you doing in round robin technique? In this case, each node or station, we can say, gets a chance to transmit, that means it can get the control of the medium, only then it can transmit by rotation in round robin manner. Question arises, what is the maximum waiting time to get access to the medium? And second question is, what is the maximum period of time a station can hold the control of the medium? In other words, what is the maximum length of packet that can be sent after acquiring access to the medium? So these are the two issues which has to be decided by this round robin protocol. Now this control of right to access can be provided in two ways. One is centralized manner, or it can be done in a distributed manner. And depending on how it is centralized or distributed, it can have two possible alternatives. What are the two possible alternatives? One is known as polling, another is known as token passing. This polling is essentially based on centralized technique, and token passing is based on distributed technique. Let us consider the first one, the polling approach. How this polling occurs. Polling is implemented. This polling approach is similar to roll call. It is very similar to the roll call performed in a class. The teacher calls the name one after the other, starting with roll number 1, 2, 3 and so on. But in this case, of course, there is some variation. Suppose there are n stations, so it goes from 1 to then n, and after n is reached, the control comes back to 1, 2, in this way goes up to n, then again it starts with 1 and so on. It goes in this way, in this manner. So in this case, there is a central node which probes each of the stations in this order 1, 2, 3, 4, 5, n, and goes on until it reaches the last station. Then it again comes back to the first station, and then it probes whether it has got data to send or not. What can happen in the process? Each and every station may not have data to send, and in such a case, the station can send what is called pole reject. If a station has no data to send, it sends a pole reject packet. That means that it has no data to send, so the control can be given to the next station, and so on it continues. And this particular approach gives equal access. So it is very fair. But since the control is being done by a centralized controller, you can easily priority can be implemented. That means some of the stations having high priority data can be allowed to send fast before other stations who have low priority data. For example, in a meeting, there is a chairperson. The chairperson can, one after the other, give permission to different person to speak. Obviously, the important dignitaries are given higher priority compared to the ordinary members of the meeting. So similar thing can be done by using polling. But this approach has very high priority, high overhead. Why high overhead? Just to gain control, give access to different station, the central node has to poll each and every station one after the other. So the overhead for polling, for selecting or finding out whether the station has data or no data, the overhead is that some time is wasted, and as a consequence it has got high overhead. Moreover, it has high dependence on the reliability of the controller. If the controller is not reliable, if it fails, again whole system will collapse. This particular medium access control technique will not be able to function. So this particular protocol has high dependence on the reliability of the controller. And since the reliability is poor, this approach is also not very popular in local area network. And the second approach, which is based on the distributed technique, is known as token passing. Is preferable, and it is based on distributed approach. And in this case, the right to access is given with the help of a token. A token is nothing but a small packet which can circulate among all the stations. There are two basic approaches in this case. Depending on the topology, it can work in two different ways. For example, in the first case, when it is token ring, where there is a physical ring, and these are the stations connected to it. These are various stations, and a logical ring is being formed a physical ring is being formed in this case. A token is circulating from, say, station A, it goes to station B, then C, D, E, F, and so on. In this way it circulates. So when this token is grabbed by station B, it acquires the right to access to send a packet. That means after acquiring this packet, it sends the data, and the data is sent through this medium. And whenever it gets the packet back, it removes the token, removes that packet from the ring, and a new token is introduced, a free token is introduced, then it goes to C. So in this way the token goes, rotates around the ring in this order. It goes from B to C, C to D, D to E, and whoever has data to send grabs the packet, this token, and sends the data, then releases the token on this ring. So in this way the communication of data can go on. Another possibility is you can have a bus type of topology, but still you want to implement this token passing algorithm protocol. So say A, B, C, D, E, this is how they are connected. So what can be done? You can form a logical ring. So here it is not a physical ring, it is a physical bus, but you can form a logical ring. Then the token can be broadcasted on this medium, shared medium, and in that token it is mentioned to for which node it is meant. That means logically B is the adjacent to A, so A will send the token with the destination address of B, and token B, the station B will grab it, send the data, then it will again broadcast the token which will have the destination address C. So in this way, using this token bus, the token can be used for gaining the access of this bus. So you can have, by using token passing, you can have a physical ring or a logical ring by which communication can be done. And this is definitely more efficient than the previous approach where it is done by polling. We have seen that the polling has a high overhead, but in this case overhead is less because token is rotating. If a station has no data to send, immediately it sends the token to the next node, the adjacent station, either logical or physical. And if that node has data to send, it grabs it, sends the data, and after that it sends the token. So this is how it goes on. And it relies on correct and reliable operation of all the stations. So as a consequence, it is much more robust, and since it is robust, it gives you higher reliability. However, later on when we shall discuss this token passing algorithm, token passing medium access control technique, in implementing a local area network standard, we shall see it has to implement various complex functions like loss token, duplicate token, and insertion of a node, of a station, deletion of a station, or let us call it removal of a station, so all these things are to be performed by this medium access control technique. Later on, we shall discuss these things in detail. Now, this token passing algorithm, as you have seen, is very efficient, and as a consequence, it is widely used in local area networks. With this, we stop today, and let me conclude by discussing that, by telling that out of the three possible approaches, round robin, contention and reservation, we have discussed the two different approaches, one based on centralized control, another based on distributed control, the polling and token passing respectively, which are based on round robin technique under the category of round robin. We have discussed in detail. In the next lecture, we shall consider different contention based techniques. Thank you.